Hello everyone. I am very happy to introduce myself. My name is Dr.S.Jeyanthi, working as an assistant professor in the Department of Physics at the Standard Fireworks Rajaratnam College for Women, Sivagasi. In this class, we are going to discuss about the ocean thermal energy conversion. Introduction. Ocean thermal energy conversion is a renewable energy technology that harnesses the heat energy stored in the ocean to generate electricity. The process relies on the temperature difference between warm surface seawater and cold deep seawater to produce power. Since the sun continuously heats the ocean surface and ocean cover approximately 70% of the earth's surface, this technology has the potential to provide a vast and sustainable source of clean energy. The concept of OTEC was first introduced in 1881 by Dr.S.Jeyanthi, a French physicist whose pioneering work laid the foundation for the development of ocean thermal energy as a practical means of power generation. Next, we are going to see about the historical background and the contribution of the scientist. Dr.S.Jeyanthi was a French scientist known for his research in bioelectricity and thermodynamics. In 1881, he proposed the idea of using thermal energy of the ocean to generate electricity. His vision was based on the principles of thermodynamics, which state that energy can be neither created from one form to another using temperature differences. He suggested that the temperature gradient between warm surface waters and cold deep waters could be harnessed to drive a heat engine and generate power. Although he conceptualized the process, he did not have the resources to develop a working OTEC system. However, his work inspired further research, and in the 1930s, his student Georges Clark built the first experimental OTEC plant. Clark's system operated on the open cycle principle using seawater directly to generate steam and drive a turbine. This early experiment demonstrated the feasibility of OTEC, but technical and economic challenges prevented widespread adoption at the time. Next, we are going to discuss about the basic principle of OTEC. OTEC works by exploiting the natural thermal stratification in tropical and subtropical oceanic regions where surface temperatures are significantly higher than deep water temperatures. This temperature gradient enables the operation of a thermodynamic cycle to convert heat into mechanical work and subsequently electrical energy. The efficiency of an OTEC system depends on the magnitude of the temperature differences, which typically ranges between 20 degrees Celsius and 25 degrees Celsius in tropical region. The working principle of OTEC can be explained through the following steps. First one is the heat absorption. Warm surface water is drawn into a heat exchanger where it is used to vaporize a working fluid with a low boiling point such as ammonia in a closed cycle system or directly converted into steam in an open cycle system. Next step is the power generation. The high pressure vapor or steam expands and drives a turbine connected to a generator, converting thermal energy into mechanical and then electrical energy. The third process is cooling and condensation. Cool deep seawater is pumped into a condenser to cool and condense the vapor or steam back into liquid form. The final step is recirculation and reuse. In a closed cycle system, the condensed working fluid is recirculated to repeat the process, while in an open cycle system, desalinated fresh water is produced as a byproduct. Next, we are going to discuss about the classification of OTEC. Depends on the location, it is classified as land-based plant, shelf-based plant, floating plant and submerged plant. According to the cycle use, they are classified into three types: open cycle, closed cycle and hybrid cycle. Now let us discuss the types of cycles in the following slides. First one is the closed cycle. Here closed cycle OTEC working fluid with a low boiling point such as ammonia or a hydrocarbon refrigerant. The process involves the following step. Warm seawater heats the working fluid in a heat exchanger, causing it to vaporize. This expanding vapor drives a turbine connected to a generator producing electricity. Cold seawater from the ocean depths cool the vapor in a condenser, turning back into a liquid. The liquid is recirculated and the cycle repeats continuously. Closed cycle OTEC systems are efficient and can operate on a continuous basis. However, they require advanced heat exchangers and durable materials to withstand the harsh marine environment. Next one is the open cycle OTEC. In open cycle OTEC, it directly uses seawater as the working fluid. The process involves the following steps. Warm surface water is pumped into a low pressure chamber where it undergoes flash evaporation. The resulting steam expands and drives a turbine connected to a generator. Cold deep sea water condenses steam back into liquid form, producing desalinated fresh water as a byproduct. In open cycle OTEC, it has the added benefit of producing potable water, which is valuable in regions facing freshwater shortages. However, these systems are more complex and require large vacuum chambers to maintain low pressure. Next one is the hybrid cycle. It combines the elements of both closed cycle and open cycle systems. It uses the flash evaporation process of an open cycle OTEC to generate steam, which is then used to heat a secondary working fluid in a closed cycle system. This approach increases efficiency and maximizes the energy extraction from the temperature gradient. Hybrid system also produce fresh water as a byproduct. Next one is the advantages and applications. It offers several benefits which make it an attractive operation for sustainable energy production. First one is that it is renewable and sustainable. Since the sun continuously heats the ocean, OTEC provides an endless supply of energy without depleting the natural resources. Next application is base load power generation. Unlike solar and wind energy which depend on variable weather condition, OTEC can operate 24/7 providing a stable and consistent energy supply. Third one is it is environmentally benefit. It does not produce any greenhouse gases, making it an environmentally friendly which are alternative to fossil fuels. The next application is the freshwater production. Open cycle and hybrid cycle OTEC system generate potable water which can help to address water scarcity in coastal and island communities. The final one is it is potential for aquaculture and cooling applications. The cold deep sea water using OTEC systems can support marine aquaculture and can be utilized for air conditioning and refrigeration, reducing energy consumption for cooling applications. Next one is the conclusion. The OTEC uses the temperature differences in temperature between warm surface seawater and cold deep seawater to produce electricity. With ocean cover 70% of its surface, that is it absorbs sunlight, OTEC is a prospective alternative sources of energy for human use. Besides, it can be used to generate electricity. It can also use to desalinate water, support deep water mariculture, provide refrigeration and air conditioning and mineral extraction. The capital cost of installation is still extremely high, and at present time the technology remains at the planning or feasibility steady stage. Thank you for watching this video. Thank you.